Everyone, now we are doing the piezoelectric experiment. From this arbitrary function generator, we are giving a sine wave through this to the breadboard and connecting this to the piezoelectric sensor. By connecting this in this way, we will get the input through this to the piezoelectric sensor. And now to read the input which is coming from the arbitrary constant, we have to connect this to the oscilloscope. This will be connected to the oscilloscope here. Okay, let me on this. And now I am connecting this and I am fixing the frequency to 500 Hertz. Yeah, this is the input we have given from the arbitrary function generator. Now to take the readings of the output, we have to connect this piezoelectric output to the oscilloscope. So I am connecting the terminals. Here we can see the output here. When we shake it, graph will be coming. Okay. This is the graph of the output from the piezoelectric sensor.
After performing the experiment, we took the readings by varying the frequency. We took input readings, input voltage, output voltage, phase difference, and we calculated the gain and plotted two graphs, one which is gain versus frequency graph and the other which is phase difference versus frequency graph.
Here we got the two.
By observing the FFT, we get a peak here. So this is somewhere around 1.7 kilohertz. It is known as resonant frequency. Since here we have two peaks, we get two quality factors. For finding the bandwidth, we need to go 3 decibels below the respective peaks to find the corresponding frequencies. Upon calculation, we get both the bandwidths and both the quality factors as 2.23 and 2.34.
We are giving the signal from the signal generator. From here, we are going to give the input. Here, if you on the LED, it will be on. Now I will be setting the frequency to 100 Hertz. And the amplitude is 5 EP, peak to peak points. Now the input given here in the LED will be shown in the oscilloscope by this wire in the channel 1. Here this is the input given from the generator, frequency generator.
We need to give 5 volt power to the photodiode, so we are using an Arduino. So we connect the ground and the 5 volt terminal from the Arduino to this
another circuit parallel to the LED circuit.
another circuit.
The ground voltage is connected to the resistance of 10 kilo ohm. And we will connect a photodiode in series to the resistor. We have connected photodiode in series with the 10k ohm resistor, and we are connecting to read the output. We are connecting the oscilloscope wires. We are giving 5 volt input from the Arduino, and here the bulb below, and we will read the output through the oscilloscope. According to the signal we are given from this function generator, we are getting the output here in the blue color and the input here, you can see it clear.
We took the readings from 100 frequencies to 100 Hertz to 1 megahertz, and we took peak to peak input values, peak to peak output values, phase difference, and we calculated the gain. So for the magnitude response, we plotted the graph and we got a graph like this. And for the phase difference, this is phase versus frequency. 3 dB cutoff frequency, we plot the graphs with the given data. The gain versus frequency graph is here. So the maximum occurs at this point at 4000 hertz frequency, and its value is 38.6964. So the 3 dB cutoff will be around 35.7, and its corresponding frequency is 50,000 hertz. So the 3 dB cutoff will be 50,000 hertz.